So I'm Robin Moffatt. I work for MUDE, and I do all kind of stuff around Oracle Analytics, Oracle Business Intelligence, data integrator, data warehousing, all that kind of stuff. And I've done it for a few years now. Previously, I worked at a UK supermarket chain, actually building out the stuff as well. Previously, I was doing DBA type stuff, so I've done all kind of things around this. I'm very proud to say I was made an Oracle Ace just last December, and I write lots of stuff for the MUDE blog. I tweet stuff, and also we've got an IRC channel, so if you're interested in OBIEE or that kind of thing, come and join us on our IRC channel. I also like fried breakfasts in full English, and I also tweet pictures of that quite a lot. So we're at MUDE. We're a small little consultancy firm. Started off in the UK, but we've got offices around the world now, and we do all kind of consultancy, implementation, training around the Oracle Analytics product set. So, source control, concurrent development, it's all part of the software development lifecycle. So this is something that in OBIEE is something that's never really been fully cracked. It's always been a little bit tricky to do. So I'm going to talk about how I think we should be doing it today. But source control or the software development is something which matters to all of us. Whether we're developers or release managers or delivery managers or testing, it impacts everyone. Because it impacts how well we do our development, it impacts the quality of what we deliver, and also in terms of projects and deadlines and delivery and happy users, it impacts the whole cycle. So it's something we've got to make sure we get right. And it breaks down into two areas. The first is source control, which is kind of easy in a way. And the next one is concurrent development, which is not so easy. So let's do the easy one first, source control. Source control, revision control, version control, I'm sure there are kind of nuances to it, but it's basically the same thing. Okay, I might get shot down for that, but I'm bulking it all in together. Because in OBIEE, it is all fairly homogeneous. It's just one great bloop. So we have to have source control, because without source control, we have utter chaos. So hands up who works on OBIEE day to day. Can't actually see you. Okay, enough of you. Hands up who recognize that. Okay? That's version control for a lot of people. I've got some files, and I'm just going to keep copies of them. I'm going to put the date of the file on it, or the system it came from, and then to deploy, I'm going to start emailing it around. I'm going to say, can you deploy this file, please? And then someone will say, well, which one got deployed? I thought it was supposed to be this one. And then they'll say, well, can you deploy it, but actually I've not got access to your shared drive. So this kind of source control is not source control, and it's chaos, and we can't do it, okay? Every mature OBIEE deployment should be using source control. I really, really believe that. And it's actually kind of easy to do. We need to have source control because it reduces the risk when we're deploying. We can say, this is a line of code that we've tested, and we've validated, and we've signed off, and is ready to move to the next environment. So rather than emailing around files or picking off network shares that people don't have access to or could change in between agreeing to release and actually releasing it, we can say, here is the point in time on the code that you're going to release. So we reduce the risk of doing deployments, that we're going to make sure that everything is included that should be, and it's at an agreed point in that code cycle. It also makes it much easier to do maintenance and development on the code, because we can start taking our code line and branching it off. And we can have little branches which come out for fixing bugs, but don't have to impact the main development that we're doing. It also means that we can kind of roll back changes that we've been doing if we need to. It makes it much, much easier. And it's also a prerequisite to doing concurrent development, which is the kind of the tricky thing which I said I'm going to talk about next. So we've got to have source control. Source control lets us see what people did. We make our changes, we commit it into source control. This is kind of teaching many of you to suck eggs, I'm sure. I don't know if that English expression translates. It's really, really, really basic. So apologies if I'm teaching the basics here and patronizing you, but from what I've seen, unfortunately, visiting a lot of clients, people need telling this. What is source control? Why should you be using it? So we use source control, we commit the changes that we've made, we can see what people changed, we can see who changed it, and we can see when they changed it. It's really basic stuff, and it's what most people have been doing for kind of 20 years or so. But the OBIEE world, maybe not in isolation, is still not caught up with it. Or people kind of know they ought to be doing it, but still aren't. So we need to have source control. We can use source control to label our code at a given point in time. We can say, I've been making these changes in this development environment, now we're ready to go and release it through into test. So we can actually lay down a label against this given snapshot of the code and say, this is what we've agreed, this has got all the changes in and nothing else. So this bit of code we're now ready to go and release. Maybe it's yourselves doing the release, maybe it's another team within your organization who do the releases. Even more important, to have a centralized, agreed place to store all of your code. So we can see what went where, when. What slice of code went to which environment when. So we can now replicate issues in that given environment, knowing exactly what code went into it. We can also roll back our code. We can say, well, we've been doing this development, we made a bit of a mistake, we can now start to unpick it and roll back because we've got the snapshot at the given point in time. You make a change, you commit it, you star it, and then you can roll back to that point if you need to. Source control, is it scary and complex? People seem to think so. That can be the only reason why people aren't doing it. They think, oh my word, I'm going to have to do branches, I'm going to have to do merges, I'm just going to use a network drive. Don't. Because it's not that scary and complicated. Maybe it is a little bit. But you don't have a choice. You've got to use source control in any kind of mature development process. Because without source control, we've got chaos and a blank screen. So we've got to have source control, and whether it's one developer or whether it's 100 of you, you've got to have it. If it's just you and you're not doing source control, start doing it, because it'll be dead easy because it's just you. You can teach yourself and then you're doing it and it's great. And then as your team grows or you leave or whatever, people come in and say, hey, that's brilliant, that's really good, you're actually doing source control. And actually it is dead easy. If you've got 100 people and you're not doing source control, then God help you, because I don't know how you're managing it. But as development scales, you need to have source control in place. So which tools do we use for source control? Doesn't matter. Okay? Lots of people will say, go and use Subversion, go and use Git, go and use whatever, but it really doesn't matter. Because the main thing is, how well is it accepted within your organization? So if you're in a relatively large organization, you'll have corporate standards, and it'll be mandated that you use Subversion or whatever. Maybe no one uses it. Maybe you're going to be the trailblazer and you're going to bring in source control. Maybe it's a smaller company. But go and pick one and learn it. And being familiar with it is much more important than using whatever is latest and trendy and cool. Git's brilliant. Okay, it's trendy, but it's also really, really, really good. It's decentralized, so you can do all your changes offline and then check them back in as you need to and bring things together. But the main thing is that you're familiar with the tool. Don't spend time evaluating, oh, should I use this one, should I use that one, should I use this one? Go with one of them, because once you've implemented source control, then you can start tweaking around with which particular tool do you go and use. But the main thing is use source control. How do we store our artifacts? So we've got the repository. We're going to store our binary objects in source control. We're going to talk about breaking things out into plain text in just a moment. But the default starting place for source control with OBIEE, unfortunately, is a great big blob of everything that you've got in your environment. So your RPD, your presentation catalog, your configuration files. Maybe you expand it out. Maybe you start bringing in your ETL jobs, your data warehouse schemas, because you want to be able to replicate that whole environment at a given point in time. So you bring them all in and you store them, and it's basically just a snapshot of your environment. It's nothing more clever than that at this point. But it's a very, very important, useful snapshot, because you can take that, you can label it, you can deploy it, and you can roll back. So the next interesting thing is, how do we actually do concurrent development? How do we make sure that we can actually start developing concurrently, making sure that people can work on the RPD at the same time? So if you're not familiar with OBIEE, the RPD is the metadata model that sits on top of your data sources. Maybe you've got a single data warehouse. Maybe you've got a data warehouse and a transactional system and an ODS and whatever, and some XML files as well. OBIEE can federate across on top of all of that and build a logical model on top of it, and then present it to the users as a single entity. So the RPD is the real guts of the operation. It's the core of it. You can't build any reports until you've got an RPD. Your reports you can develop concurrently because it's just an online system. You go and create them. You'd expect to be able to do that. But the RPD is where it all intermeshes, and it's where the problems come when you try and do concurrent development. It doesn't scale well. Trying to do concurrent development, in a serial manner on the RPD. Because when one person's made their change, it's a binary object. So you make your change, and now that change is there. So someone else comes along and says, well, I want to make my change. They have to wait for you to have done yours, and you can pass it over, and you're playing pass the parcel with it, taking it one at a time. And now if you say, well, mine's ready to go to release, and users asking for this particular change, you go and deploy that binary object, that RPD, and you're going to take everyone else's changes with you. So then you end up with having to do kind of big bang release cycles. You say, well, every 6 months we're going to deploy the RPD, and we're going to build all of our changes and put them all in, and then we're going to cross our fingers and hope like hell that it actually works and doesn't break things when we put it live. Or obviously we go through testing cycles, which are then these huge monotonous testing cycles that take weeks and weeks and weeks. And we get bugs raised, we have to go back and we have to go and fix them all, and it's all very big and slow and it doesn't scale. If we've got a project that's demanding a certain deadline and we've got a bunch of work that needs doing, we can't say, well, we'll just add extra RPD developers to it. Because as you add them in, your development rate is not going to go like that as you would expect. It's kind of going to go up a little bit, and then it's going to plateau, and it's probably going to go down because you're all scrapping over how do you actually manage this RPD. So the way that we need to approach it is using something called feature-driven development, which I'm sure is familiar to a lot of you. So we break up our projects, our development requirements into these features. So maybe adding a new logical dimension, adding in a table, fixing a bug. We do them in little piecemeal, individual isolated components that can be deployed individually and in isolation and that aren't related to each other. We work out what work needs doing and we break it up into these features, which ones are dependent on which ones can be done in isolation, and then we actually work on them concurrently. And it's one of the central tenets of agile methods, but you can also use it in just lowercase agile, lowercase a agile, just to flexibly work on the RPD, do things in individual features, and then as they're finished, bring them together. So you can do these features, you can do them one at a time, you can release them once they're finished. So you develop them in a sandbox, in your own little environment, you test it through to completion, and once it's ready, then you bring it back into your mainline. So you don't have this idea of this huge, humongous single RPD that everyone's trying to do development on, and it's got everyone's changes in. And when you want to release it, you have to say, well, is everyone finished doing their changes? Do they all work? You can actually say everyone's got their own version, they make their changes, and when they're happy with them, they merge it in, which means that what you've got in your mainline is always ready to go ahead and release. You always know that you've got good quality there because it's been tested in isolation. So then you do your integration testing, and it's all good. So you don't end up with a situation where one person's development is blocking everyone else's. You've got some developer who's hit a particular problem with their development, and instead of getting it finished on Friday, they need another 2 weeks. But you've got all these other developers who have committed to a given deadline, and the business is screaming blue murder. Why is our release not in yet? You say, well, we can't release it because we're going to take Joe's changes with us. And they say, well, can't you just unpick those? But if you unpick them, now you're changing what you've tested and agreed with the business is going to be released. Now you need to retest it because you've changed it, because all those changes were intermeshed like that. So you have to then unpick it, which is just as risky. So feature-driven development is kind of what we want to be doing. So we've got this idea, this OBIEE development nirvana that we're going to try and get to. We want an RPD development rate that scales with your team. So as you add in more developers, your development output can increase proportionally. We want to be able to do feature-driven development because it rocks, because it's a much more sensible way to manage your delivery. Whether capital A or lowercase a agile, it really makes things much more flexible. We're going to have source control because A, source control rocks, but also it enables this feature-driven development so that we can track our individual features and when we've finished with them, merge them in together. And a nice little upshot of this is that it means we can start looking at doing continuous integration. Continuous integration is not new. People have been talking about it for years, people have been doing it for years. But in the OBIEE world, kind of like a prehistoric era where dinosaurs were crawling planets, it seems to be, you've got what people are doing, you've got everyone doing source control, and kind of over there you've got continuous integration. So it's what we'd love to be getting to. But out of interest, who's doing continuous integration with OBIEE? Bravo, that's very good. So unfortunately you'll be in the minority, you are in the minority. So it's what everyone ought to be doing, and it shouldn't be that difficult. So it's a baby steps approach. First off, we need to be doing source control. We've got to do source control. And then we can start saying, well, we've got source control. We've got a snapshot of our code at a given point in time. So maybe now we can automatically deploy that, and we can automatically test against it. And then we can start doing maybe automatic releases, but that's a bit scary. So that was the nirvana. The brutal reality of it is that the OBIEE does not support this out of the box. It doesn't. Okay? There's various options which I'm going to talk about, but there is no perfect way. I spent quite a lot of time looking into this and working out, have we just missed a trick somewhere? And I'd be really interested to speak to everyone using OBIEE, but particularly you guys, how are you actually doing this at the moment afterwards? Because it doesn't do it out of the box, and it never will until Oracle either change how they're storing the RPD on disk, or maybe they integrate it into the product. But as it stands, it doesn't do. And that's kind of, maybe sounds obvious, but it's actually quite important to state, because sometimes people will say, how do we do this? What's the perfect way? You say, well, you could do it like this, and they'll say, oh yeah, but this objection, this objection, this objection. Because it doesn't do it out of the box. There is no way. So as we're going to see, there's different ways of doing it, and they've all got their limitations. So they all require, you've got to have a defined process. How are you going to do it? And if you've got a defined process, you've got to make sure that you train people on it. So this is where people start running away from doing concurrent development, because they say, A, that's a process, that's going to constrain us. B, oh, we're going to have to train all these people. Training takes time, and we're going to have to invest in people. I'm not sure if we're going to do that. And there's also this issue of they want something which is going to control all of their developers. So regardless of ability or experience, they're all going to work in the same way, and it's all going to work. They're just going to be able to get lots and lots of people to do RPD development, and it will all just scale like that. But there is no way of compelling bad developers to be good. You've got to have a team who are going to understand how to do the concurrent development process you've adopted, and how to make sure they do it right. So to make sure that actually happens, you need a kind of a source master or a dungeon master. Does anyone recognize that character? Is that just a UK thing from our childhood? No one recognizes. Okay. Go and look at Dungeons and Dragons, their cartoon, because that's when people talk about source master, I always think of the dungeon master. That's obviously lost on you guys, I'm afraid. So you need someone who's going to oversee and understand what it is that's happening with the RPD. What is the development plan? What are the various projects and people involved in it? What's it going to look like once it's finished? Because at some point, you're going to have to merge all of these nice features back together, and you are going to get conflicts. So you need someone who says, well, I understand that we've got this here and this here and this here, and what it needs to look like after it's all been brought together is this, because they've got an overview. So they're going to have to get involved in the kind of the delivery management side of things as well, but also understand the concurrent method that's been adopted. So you've got to have someone there. You can't simply chuck a process at a bunch of developers and hope it works. Okay, so how can we do concurrent development? I think there's 4, possibly 5 ways. I'll talk about the 5th afterwards. So we've got 4 different ways. We can use online editing, we can use multi-use development, and then we can use source control, either storing the RPD in XML or storing it as a binary object. And I'm sorry to say, they all suck. In fact, they all suck. It's 2015, for heaven's sake. It's not 1995 when people were kind of starting to think about source control. So they all suck. So we're going to talk about which one sucks the least, and what do we need to do to mitigate that suckiness. So the first one, the most obvious one for concurrent development, is online editing. So this is where we take the BI server, it's running the RPD, and as a developer, we run the administration tool, and we connect directly into the server online, and we make our changes. So it's all instantaneous. Okay, so it's nice, you don't have to deploy each time, but the problem is when we try and do concurrent development. So remember, we're talking about concurrent development here, we're not talking about just development. So for concurrent development, online editing doesn't work. Because when you check out an object, because we're online, remember, so you need to check it out, so the server knows that someone else can't also make those changes. So you check out the object, and now you take a lock on it, which you'd expect. But the trouble is you take out a lock on the whole business model generally. So whilst you're making a change to a little part of it, it takes out a lock much, much higher up, which means that other people can't work alongside you. Maybe they can go and work on a completely separate business model, separate parts of the RPD, but in practice, development's generally going to be focused in much the same area, which means that for concurrent development, online editing really doesn't fit the bill. You also have this one, transactional update failed, which if you've done online RPD editing, you'll have seen. Anyone done online RPD editing and not seen that? Okay, phew. So sometimes that's because you've done something stupid. Okay, it could say you've done something stupid, but sometimes it's because of a bug. And there's one around dimensions that every time I do online editing, it always hits me. So you go and do a bunch of changes, and you go to check it in, it says no. So then you have to save it offline and redeploy it, and it all gets a bit manual and torturous. So there's also that problem. So online RPD editing, there's also no audit of changes made. It's online. So you make your change, you save it, it's stored. There is no way of saying who changed what when. The killer punch is that there's no native integration with source control. We've no way of saying, this particular point in time, let's store that all in source control, let's make sure we can now tag it for release, we can roll it back. Doesn't happen. You're now back to exactly the same place as in a non-online RPT where you'd have to go and check in the objects manually. So it's not integrated into the workflow at all. Online RPD editing is useful for individual developers. So when we're talking about feature-driven development, and developers have got their own sandbox in which to work on their features, editing the RPD online is very, very useful because you don't have to deploy each time. You have your little sandbox, you're just you working the RPD, doesn't matter what level the locks are being taken out at. You can work around the kind of the transactional update error because you've got your own little sandbox and it's much, much easier to work in that. So for individual developers it's great, but to actually adopt that as a concurrent development approach really doesn't. I went to a customer once and I said, how are you doing concurrent development? And I said, we're doing it. I said, oh, brilliant. How are you doing it? And they said, well, we're using online RPD editing. I said, but don't you find that the locks always clash? And they say, well, we take it in turns. We've got this cup here, and when I've finished making my changes, I pass it across to my friend over the desk, and then he's got the cup and he makes his changes. That's not concurrent. That's serialized. Okay, you're just taking it in turns to do it online. So if you ask Oracle, how do you do concurrent development, they'll say, well, you've got multi-user development. So this is what ships with OBIEE out of the box. And you have to set it up. And what you do is you take your RPD and you carve it up into these projects. And then a developer comes along and they check out a particular part of the RPD. So then they'll have their own little subset RPD. And they go and make their changes offline in isolation. They can actually deploy that RPD and test it. Okay, it's quite good. And then they merge it back up into the master. So multi-use development, it's not bad actually. It's the only viable option that you've got out of the box. And it works quite well. So it's the closest thing that we've got out of the box. And a lot of people do use it because it kind of works. But one of the problems is that it puts the onus for resolving conflicts onto the developer. When you've made your change and you say, all right, I'm ready to push that back up to the master, it'll do some comparisons, what's changed here, what's changed there, and it'll say to the developer, which side of the conflict would you like to resolve it with? Would you like to use your changes that you've spent a week doing, or would you like to use someone else's changes? And the developer's going to say, now let me think about that. Do I want to throw away all of my work, or do I want to use someone else? They're going to use their own, aren't they? But they're not necessarily best placed to understand the implications of that. So if you think back to what I said about making bad developers good, now you're putting all of the power into the developers, who generally are going to say, well, I'm going to use my change. Obviously, developers are they're out to do right, but they're also out to get their work done. So ideally, you won't see that power sitting with the source master, the dungeon master, rather than the developer. There are known bugs with it. There are known bugs with everything, but there are some particularly problematic ones with multi-use development around parent-child tables and variables, which mean that you then have to circumvent the process and go and edit the file separately and then bring it back into multi-use development. It doesn't easily support feature-driven development, and it also doesn't integrate with source control. You still end up having to go and pick up the RPD files manually, pull out the presentation catalog manually, and so on. So multi-use development, there's nothing wrong with it, but not integrating with source control directly is a bit of a problem. We've got to have source control. Oops. So we need to be using source control because it enables us to manage our features separately and have an overview of what's happening and bring it in together. So we use branch-based source control. Each feature sits in a branch. When a feature's been tested and signed off, we merge it back into the mainline. And we have our source master overseeing those mergers. But the problem is that source control will do its mergers itself. It will try and bring the objects together, and if they're plain text, it will kind of work out if there's any conflicts or not. But if it's binary, source control will just chuck it out and say, two binary objects, no idea if they match or not. You now need to go and resolve that. Which means that you need to go and load up the administration tool, you need to work out your merge candidates, and it's fairly tortuous. Okay, so we end up with this. You have to go and, anyone who works with OBIEE, hands up who could tell me now, hands on heart, what the original, customized, and modified is. Yeah? Their various terminology, they've actually got significant meanings when it comes to resolving merge conflicts. But they've got this terminology which has got some reason somewhere back in the midst of time. But trying to do a merge of the RPD manually to accommodate a source control method can get very tricky. So what happened a couple of years ago was that Oracle brought out with OBIEE 116 this thing called MDS XML. So MDS XML breaks up this binary object, this binary RPD object, into a bunch of XML files that sit in a bunch of folders. And suddenly it looks quite nice because we've got a folder structure, we've got a bunch of files that are plain text, logically describing what the RPD looks like. So we start thinking, well, is this actually going to be the answer? And there's quite a lot of excitement around the time and quite a lot of articles written saying, well, MDS XML and Git, this looks really promising. So option 3 on our list for concurrent development is that we use source control and we use the RPD that's stored in MDS XML. So the thinking goes, we'll package up all of our environments and stick it in source control. We're going to use the RPD in MDS XML. And because the RPD is in MDS XML, and because Git can merge code into plain text, we can use Git to merge the RPD. Does it work? Well, let's have a think. It works in very simple use cases. And this is the kind of stuff that people wrote about at the time. You can do a bit of development over here, and you can do a bit of development over there. So we've got one change here, dim stuff. We've got another change here to dim stars, completely isolated, 2 different changes, 2 branches in Git. So you think it's going to be able to do this, branch A, branch B, we're going to merge it back together because we've got separate MDS XML files. We can just bring it together like that because they're unrelated. And the point is, by storing it in plain text, by storing it in a directory structure, Git can work out if there's a conflict. So instead of saying, we want to merge these 2 branches and they're just full of binary objects, at which point Git or any source control tool is going to say, binary, no idea, over to you. And then the developer or the source master needs to go and figure it out. Git can actually now say, well, I've got a file here, I've got a file here. They're completely unrelated. One's changed, another's changed. That's fine, I'll merge that, no problem. And that's what Git and source control does, and that's great. So we can actually merge it, and then the resulting file, there's our 2 commits. The resulting file works. We end up with an RPD with both of our changes in. Because you open up the RPD, back off disk, back off MDS XML, and it's all great. So MDS XML merging can work. And that's what a lot of people at the time said. It can work. Look, we can do these merges. It's brilliant. But what happens if we dig into it a little bit more? So we've got 2 more developments we're going to do, but we're going to make changes in the same logical table. Okay? There's nothing wrong with wanting to do that. So we're going to add tax in one, we're going to add margin in another. So let's say, to back up this example, we're bringing in data from different source systems. Because that's what OBIEE does. It's great. It federates across multiple different sources. So maybe we've got one project to bring in tax from a SQL Server system. We're going to bring in margin from a different system. So they're separate developments. And we say, right, we're going to add those columns into the logical fact table. They're at the same grain, the same dimension. They sit in the same logical fact table. So we're going to bring them in together. But at this point, the wheels kind of fall off. Because what should happen is this. Because logically, we've got 2 new columns. They're completely unrelated. So logically, you should be able to merge them like that. Looking at it, that's what you'd expect to do, isn't it? But what Git does is this. It throws its toys out. It says, I've got a single XML file here, and it's changed in both places. What am I supposed to do with that? Because it doesn't understand that the XML, let alone MDS XML, is structured. It doesn't understand the concept of a logical column entity within the structure. So it says, well, I've got 2 plain text files, they both change, what am I supposed to do? Rather than saying I've got a logical file here, which is, a file which describes a logical table. Within a logical table, you have logical columns, and those 2 logical columns should come together like that. It doesn't understand that because it only understands plain text. It would have to go and parse the XML to understand what it was being expected to do. So now the user's got a merge conflict that it needs to go and figure out. We get merge conflicts when we do merges with a binary RPD, but we resolve those with the administration tool, which has got a graphical interface to explain, here are your different merge candidates, here are the columns that conflict, and so on. Whereas if you try and merge XML, you literally have that to work with. You have to go and work out which particular elements do I bring together. That's no one's idea of fun. The third reason, or the third side to MDS XML, it breaks down into the good, the bad, and the ugly. Okay, I don't know if you've seen the film. So the ugly side of MDS XML is that under the covers, it uses a logical ID for individual objects. and it uses that as the file name for those objects. So this is more of a contrived example, and some people have objected because it's contrived and you'd have process around it. But the point is, if you create the same object in separate branches, they're going to have separate IDs. So I know that GCBC sales table is the same as that one. Two developers have created the same table, but Git doesn't. Git sees it as the same as different files because it's got different IDs. It's a unique ID, it's a globally unique ID. So two people create the same object, it's going to have a different ID, which means the file name is different, which means that when you merge it, Git says, I've got two individual files. That's great, I'll bring them together. Because why wouldn't it? They're two separate files. So then it brings it together, which means that you end up with an RPD that looks like this. I've got two GCBC sales tables, and when I go and try and edit one of them, I get that error. And now my RPD is kind of screwed. Now I need to go and revert the merge and work out quite what the problem was. So yes, you can fix it, and yes, you shouldn't have that in the first place. But my objection is that when you do the merge, you'll run the merge and Git will say, it's all great, I've done the merge, and you think, brilliant, I'll move on. It's only when you come to open the RPD and go and look at it, you realize, oh, crap, I've got a problem now. So it's not that it shouldn't do it, or you shouldn't create two objects at the same time. Absolutely you shouldn't. But it doesn't tell you that it's duplicated them. That's my objection. And it's what the equalize function is designed for in the administration tool. Because if you do a merge from the administration tool, it will say, I've got two objects, they've got the same name. I'll synchronize the unique identifiers, so now they're the same. I'll understand that I should only have that table once. So Git and MDS XML, you can't merge the RPD except through Oracle's toolset. Well, you can, but not reliably. You can come up with examples where you can, but fundamentally you should be using the Oracle toolset. Git MDS XML is structured. Sorry, MDS XML is structured, and Git doesn't understand that. Git tries to merge it as a DOM plain text, which means that you end up with these unnecessary conflicts. Yes, you can put process around it, but that's additional process. If you simply say to Git, go and merge this, it's going to throw its toys out at the pram at things that it shouldn't do. But if you merge it with the administration tool, it would say, that's fine, they're separate, I'll bring them together. And what Git doesn't do is says, oh, they're the same, I'll not bring them together, because it relies on the unique identifiers. Git doesn't understand that they're logically the same. So yes, you could equalize the RPD before merging it with Git, but that's additional process. So it works for simple cases, but for me, it's not reliable enough. You need too much process around it. So the fourth option that we've got is that we do source control and the binary RPD. So bring everything into source control. It's in source control, double thumbs up, that's great. We can do release, we can do rollback, it's all brilliant. But we're going to use the Git flow branching method. So if you're using Git, there's something called Git flow, which describes the method to follow for your branching strategy. And it's pretty simple once you get a head around it. You do your separate developments, you bring it in, and you merge it together. So far, because you're storing the RPD as binary, this kind of looks like what we had before, which is we're using source control, we're doing merges, the merge fails because of a conflict, and now we've got two binary RPDs to go and merge. We have to go and figure it all out, which is torturous. But there's actually a way around it, because what we do is we have a bit of secret sauce. We write a script, and what the script does, it's a very simple script. It works out which our merge candidates are. Because Git understands which the merge candidates are, because Git has been tracking them. Okay? Git understands, here's my main line going through here. I've brought in from the first feature, brought it back in. That's now my modified one. There's my original. And when I bring the third one back in, we know we've got a conflict, and there's the current one. So Git knows which those files are. So all we need to do is write a file which is going to rename them. Like so. There's your merge files out of Git, and those are now our merge candidates. We can call the admin tool programmatically. We can use the command line tools programmatically. Go off and try to merge these files. Okay, because we've got our merge candidates, so we can automatically try and merge them. And if that merge works, so for example, we've got two new columns in the same logical table, it's going to merge that, happy as anything. And now it's merged it automatically, we can commit it back in. Job done. But if it doesn't merge successfully, and it's not always going to, you are going to get merge conflicts. So if it doesn't, it'll launch the administration tool, and it'll say to the user, here are the merge candidates that you need to supply to the administration tool. So it's kind of what we've always had all along. It's just adding that last little bit of the logic to it, which is if you follow the git flow branching method, your merge candidates are defined for you, and then you can use those to accelerate the process. You can automate your merge, or you can at least help the user along the way with when they do that merge. So which method sucks the least? We've got 4 different methods. I'll talk about the 5th just in a moment. So we're going to look at them. For me, the best one, the most reliable one, is what I just described. Source control, binary RPD, but with the script which identifies and automatically merges if it can. Because we can have multiple developers. By definition, it integrates with source control because they're using source control for it. Feature-driven development, I'll be honest, easy use, it's only that easy to use. We've still got a script, it's still whatever. And this is what I mean before with the harsh reality. There is no perfect solution. There is no easy solution. But for me, this is the best of a bad bunch. The second option is using MUDE. If you're using MUDE currently, don't go and rip it out, just because some guy at a conference said. MUDE's kind of, it's all right. It could be a lot worse. But it doesn't integrate with source control. Because it doesn't directly integrate with source control, doing feature-driven development against it becomes a little bit clunky. Again, easy use, medium, you have to set up your master RPD, you have to set up your network shares and so on. So it could be worse. A bit of a, Source control, storing your RPD as MDS XML. For me, it's not reliable enough. You have to have too much process around it in order to make it viable. So yes, it can work, but for me, not reliable enough. And online editing, we've got to include it, but it's dead easy to use, sure, but it doesn't integrate with source control. You can't seriously have multiple developers on it. You can't do feature-driven development against it. But don't write it off because as a sandbox development method, it's great. So to recap, the harsh reality is that there is not a simple way of doing it. You have to pick the one which you prefer and define the process around it. And that process, by definition, is going to be integrated with your organization's delivery method and release structure. You're going to have to hook into that, so RPD development is just part of the puzzle. Again, that's why there is no one perfect method, because everyone's got different ways of approaching their development. You could come up with the most perfect solution in isolation, and then you're going to try and apply it somewhere, and they say, yeah, but we don't work like that. We don't use Git. We use Subversion. Or we don't do that, and we need to let such and such team have control of doing this. So it all has to have process defined around it, which hooks into how you'd actually do your delivery. You need to have this little dude here. You need to have a dungeon master who'll oversee the merge process, who'll understand. Even if you're using MUDE, even, God help you, if you're using network drives to share your RPD, you've got to have someone who oversees and understands the RPD, what's going to happen with it. The final point I want to make, or the penultimate point I want to make, is that you need to make sure that it all actually still works. If you're doing concurrent development, you need to make sure that as you bring in your features together, that your mainline code still keeps on working. Or indeed, your features still keep working. And you've made your change to your feature, so you need to automate your testing. If you're going to do this kind of thing properly, you want to automate it. You can automate it in some nifty ways. You can use enqueue command to simply fire the same logical queries at the BR server and make sure it's still pulling back the same data as it ought to. As you write new features, you can write little unit tests which encapsulate what that feature should be delivering and include that in your regression test suite. So each time you merge, each time someone changes something, you run the test and you make sure, are the reports still producing the data they should do? And that's dead easy to do at a logical level. You can even take it to the next level, which is visually, are the reports still showing the same data? So run a tool which pretends to be a web browser. We're not talking Selenium here, we're talking Phantom.js. You actually go off and you are a web browser, but a scripted one. And you go off and you run it before and after, and you compare them visually, but programmatically. And that also will be part of your test suite. So to summarize, if you're not doing source control, go and do it. Okay? Forget about concurrent development, forget about Git MDS XML, all this kind of stuff. Just go and do source control. Do that and then start building on it. But if you're not doing it, no excuses, you need to be doing it. Even if you're just one developer. If you are doing source control, then you can look at doing concurrent development. Concurrent development is not for everyone. You've seen the kind of process that can be involved with it. So if you've got the requirements, if you've got the project delivery requirements that need it, then go ahead and look at doing it. But don't feel that you have to. It's just an option which is there in the toolbox. But remember, you need the process around it. You need to be prepared to take the time to define how's that actually going to work for us, for our organization. And for me, the only way to safely store the RPD and to merge it is binary MDS XML. Is binary, not MDS XML. Okay, so thank you very much. I've just come in 30 seconds on the time. So, any questions, please? Okay, I have a question for you. People who said they're doing concurrent development, continuous integration, how are you doing it currently? Yeah. Okay, and you're using that with OBIEE? With OBIEE? With Oracle Business Intelligence? Okay. No, it's all good stuff. And yeah? Okay, yeah, configuration manager. Yeah. And the guy behind you? Mm-hmm. 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 Good. Okay. Good stuff. Okay. Any questions? Yeah. Say again. Make them available. Is that the, are we going to make those scripts available? I'll have to check, but I'll try. Yes. There are my contact details there, so get in touch. If we can't do them publicly, I'll see if we can share them anyway. Any other questions? Okay, so thank you very much for your time. There's a voting thing on the way out, so don't press the red one. I think that electrocutes you or something. But if you can make sure you press the green one or the orange one. Okay, thank you very much.